friends, so in this video we are going to see how to use a function pointer. So what is a function pointer? Function pointer is just like any other pointer that points to the address of the function. So the input to this pointer will be the function address. So let's see how it can be done. So here in this code I have put in some basic function as plus, minus, multiply and divide, which is returning the respective values. And now we want to create a function pointer that will point to these functions. So how can we do that? So first we need to see the prototype of this function pointer. So how can we do that? So let's declare the function pointer. So first we need to see the function pointer prototype which we want to point it. And here we have the function having return as int, and we have parameters as int and int. Okay, and they are returning some int value. So what is our function pointer now? So it would be first the return type, then we have bracket, and here we have to name the pointer. So you can take any name here, and then we want to have the parameters. So we have int and int as a parameter to this function. So this way we can declare a function pointer. So how can it be pointed to the function which we want to access? So we have we just have to do, so we have ptr equal to, we need to have the name of the function. So let's take the first function, and here we have plus, and we just have to pass the address of this plus, and let's have plus here and then semicolon. And how to call this pointer? So we just need two parameters here, was of integer type for a and b, and let's see what is the result here. So we just have to do ptr, this is the pointer, and we just need to pass the values. So first is 1 and second will be 2, and we need the value as a 3. So let's take as integer x is equal to the value, and let's print also here. So if you take the value of x, so we have, let's save it and let's run it once. So we'll see the value of x will be 3. So we are not directly accessing this function. So if we want to directly access, so we have to do something like per plus and putting the values as 1, 2. But in this case we are pointing the variable, this function pointer, to the address of our function. So we can point this function pointer to any of the function which have the return type this, and the parameters, they have two parameters. So we should be cautious about declaring the function pointer so that it can match the prototype of the function we are pointing to. So what is the use of this pointer? So it can be used as a callback function. So we are providing the address of the function to this callback. So when some event occur, it will have this values on that. So what's the real use of this function pointer? Let's see that. So these function pointers are heavily used in in the library calls, where we are inputting some callback functions. Like we have a signal function in which we are providing the callback address. So in that case we have this function pointer. So let's see how they are utilizing this thing. So let's take one more function, and let's call it as int, and we have arithmetic operation, right? So we are having the argument of this function as the function pointer. So we'll have int, then we have star ptr as we have discussed earlier, and here we have int and comma and int, right? So we are passing the address of the function to this particular function, right? And we are also inputting some value. So let's have a as this and int p. So these two values will be input in this function, whatever we pass to this arithmetic operation. So when we call this, we need to have ptr, then we have a and b, the values we are inputting from this function, and we'll get the result over here, right? So if we need to print this, so print f, then we have, because the return type is integer, so we are taking percentage %t here, okay, and then right, and then we are returning the value the same, right? Let's take this, we're just printing and just passing the values. So when we call this function with the parameter as the address of the function, it will give the desired result. So let's first of all, let's have arithmetic operation, then we are passing the value of first let's take for example of plus, right? So we need a plus operation, and we don't know what type of function we are passing here, so we can pass any function. So this operates as a wrapper over this function too. So we have plus here, right, and we are passing the address over here, and then we are passing some values. Let's this time we take 2 and 5, right? So if we compile this setup, so we'll have 7, right? So we'll get the result as 7. So if we want to pass any other function depending on the event that create the function, so we may have minus here, right? And we need to have subtraction of 5 and 1. Let's take this example. So if we'll have 4 values. So this way we have created a function in which we are passing the address of the function and inputting some variables on which we want some operation, and we don't know what type of event will cause this function to pass to this arithmetic operation. So this way we can use these things in library function in which we need to have some fallbacks.